Hello everyone, we are Group 1 from Section 15 and today we will present our EMT project titled Non-Invasive Glucose Monitor. First, let me introduce our group member. Abdul Halim will introduce the project and explain the problem with current glucose monitoring methods. Next, Omar will present the objective of our project. Then me, Javani, will demonstrate our simplified prototype and explain how glucose concentration affect the sensor readings. Finally, Yessi will explain the EMT concept and theory behind our project.
Diabetes requires regular blood glucose monitoring, but the traditional finger prick method can be painful and inconvenient. Non-invasive glucose monitors offer a safer and more comfortable alternative by measuring glucose level without drawing blood. This project focuses on the development of a non-invasive glucose monitoring, explore its background, working principles, engineering concepts, and the role of teamwork in biomedical intervention.
So we have three objectives. So the first one, it is to investigate the relationship between dielectric loading and resonant frequency perturbation in a resonator-based sensing system. So our second thing is to design and develop a non-invasive glucose monitoring concept using electromagnetic sensing techniques. The third one, it is to evaluate the feasibility of using a resonant frequency perturbation as a method for our non-invasive glucose detection.
Next, we move to the concept and theory. For a non-invasive glucose monitor, in monitoring glucose level, we must know that the glucose are polar molecule, but it does not carry any net charge. From its concentration, it can cause the water molecule to displace, thus dipole density is altered. When the glucose level increases, the overall permittivity also decreases. The ability to polarize and store energy becomes lesser. For the concept, biological tissue like skin and blood are classified as lossy dielectrics. They only give response when exposed to the electric field. So what is the response? First, permittivity. As what I mentioned before, permittivity is the ability to polarize and store energy. Second, loss factor, which is the ability to dissipate energy in the form of heat. All this behavior known as complex permittivity. The complex permittivity can be determined from the subtraction of the real permittivity with the loss factor value. Next, moving to the dielectric loading. It happens when the material being loaded within the electromagnetic field of resonator. When we use the device, finger is placed between the sensors. The electric field able to penetrate into the blood from the skin. When this happens, there is changes in capacitive and also inductance. To be clear, the higher the glucose, increase the sensitivity, which causes the loading effect become more visible. Lastly, resonant frequency perturbation. RFP is a mathematical method in measuring the small changes. Using materials able to perturb the initial value of resonant frequency and also the quality factor. Resonant frequency depends the changes of the real permittivity, while the sharpness of the response depends to the loss factor, which can affect the quality factor. However, those materials has its drawback, as it can absorb other signal easily and easily influence from the surrounding factors like temperature and also skin hydration. Solution to the problem has been discovered by using a resonator with high sensitivity to track accurate frequency and also to filter out the noises from the original glucose properties. To summarize, when glucose is increasing, permittivity and also capacitance will be lessened. The resonant frequency increases while dielectric loading decreases, and lastly, loss factor decreases as well as increase the quality factor.
I will demonstrate our simplified non-invasive glucose monitoring system. First, the material used are an Arduino Maker Uno, breadboard, aluminum foil electrodes, 4 jumper wire, USB cable, and 5 units of 10 kilo ohm resistor. We also prepared 3 samples, which is the pure water, low sugar water, and high sugar water. Next, we connect all the components on the breadboard and connect the Arduino to the laptop using the USB cable. Then we paste the Arduino code into the Arduino IDE and upload it to the Arduino board. The aluminum foil acts as the sensing electrode. When the liquid is placed between the foil plate, the Arduino detects different capacitance values based on the sugar concentration. Pure water gives the lowest reading, while low sugar water and high sugar water give slightly higher readings. In this project, we use 5 units of 10 kΩ resistor. However, lower resistance make the sensor less sensitive, causing smaller difference between the readings.
Non-invasive glucose monitoring represents a groundbreaking advancement in biomedical engineering. By replacing painful finger pricks with electromagnetic sensing, we offer diabetic patients a safer, more efficient, and pain-free quality of life. This project highlights the power of collaborative engineering in creating future healthcare innovation.